I'll get started. Thank you everyone for coming to this session on platform engineering versus DevOps. So first introduction, my name's McCarthy. I am a principal engineer at Versant, so a consultancy based here in Australia. I primarily focus on platform engineering, DevOps, dev experience, predominantly in the Microsoft domain. I'm a Microsoft MVP for developer tools, so kind of ties into that platform engineering space. I started off as a .NET developer about 8-9 years ago and progressed from .NET into infrastructure, ops, then DevOps, cloud. So I've kind of run that whole gambit. Now I use those kind of cloud skills to help developers get their code deployed, get their systems running. And I'm an all-around tech enthusiast, do a lot of talks on AI, GitHub Copilot specifically, and other emerging technologies as they go through. And now, as everyone through the conference has been doing their kind of AI-generated superhero and things like that, I decided to be a bit different, and I decided to ask AI to make me into a server rack. So there's me as a server rack. Cool. Alrighty. What are we going to talk about in today's session? So we're going to cover what is DevOps, good place to start. We're also then going to cover what is platform engineering. We're then going to get to the crux of it of platform engineering versus DevOps. And then I'm going to go a bit more into platform engineering, what I call the platform engineering iceberg, the goals of platform engineering, and then I'll touch briefly on kind of internal development platforms and kind of how they tie into everything as well. First, a disclaimer. Everything I'm presenting is my opinion and built on top of my experience. But I kind of hold this saying really close, which is have strong opinions, but they're loosely held. So generally that means that I'm really passionate about the opinions I have. That doesn't mean they're set in concrete. Things change, as we all know in IT, things change really quickly. So you want to be able to take in more information and say, okay, well, my views changed as things went along. As such, I encourage everyone to challenge me in this talk. If you disagree, I've hopefully got time at the end for questions and discussion, and I'd really like to hear your input on kind of where I put this talk. All right, so let's start at the beginning. What is DevOps? So hopefully everyone's kind of aware of this kind of picture where we have our kind of plan, collaboration, we go into workflow, we develop, we deliver, we operate, and then we go back into plan. And we just keep cycling around. So let's go through a definition though. Now, this is the definition off the Microsoft Learn page. So this is not my definition, but we'll just cover it quickly. So DevOps combines development, dev, and operations to unite people, processes, and technology in application planning, development, delivery, and operations. DevOps enables coordination, collaboration between formerly siloed roles, like development, IT operations, quality engineering, and security. Teams adopt DevOps culture, practices, and tools to increase confidence in the applications they build, respond better to customer needs, and achieve business goals faster. DevOps helps teams continually provide value to customers by producing better, more reliable products. Big, huge mouthful. So that's the ideal state. But what is it really? And I'm sure quite a few people can empathize with this picture here. DevOps engineering tends to be an engineering team that's responsible for unblocking everyone's problems. It's kind of, you're under-resourced, you constantly got all these development teams going, hey, we need stuff, we need to do this, you're blocking me, I can't get my product delivered. And the expectations really don't match what you're resourced to do. This seems to be, in my experience, a really common environment to be sitting in. So let's move on now. What's the new thing that's come out? And this is platform engineering. So some of you may say, if you'd went to Will's session yesterday. He spoke about platform engineering, brought up this slide as well. And this is really just talking about the different areas within the platform engineering and how you kind of You start right with right templates, and then you shift left notifications, so shifting left towards developer, shifting right towards the infrastructure. And it's this big infinity circle, again, same as DevOps, where everything is a cycle. It's cyclical and it keeps going. So what is platform engineering? Now, this is my definition of platform engineering, so it's going to differ from what you might read online. So platform engineering is the practice of empowering organizations to uplift their engineering teams by providing a platform for the automation of software delivery within their environment. The key pillars of a platform are standardization of tooling, implementation of standardized IAC, so infrastructure as code patterns, repeatable automation of deployments, monitoring and observability, integration with security tooling and frameworks. So platform engineering seeks to support all of these pillars to enable development teams to focus on what they do best while keeping operational environments manageable, secure, and scalable. So what I'm going to do now is make sure people are awake. We've had coffee, and get you a bit involved. So I'm going to ask a couple of questions, and I'd like to see, so just raise a hand. So which one of these two is an engineering team? So we have our DevOps guy, which is on closest to me, because I can't tell left and right at the moment, so closest to me, and platform engineering furthest. So let's start with DevOps. Who thinks DevOps is an engineering team?
Is or should be?
Is, currently. Yep, and then platform engineering? Yep, so I'm going to say platform engineering, because DevOps shouldn't be. DevOps is a culture, not a team. So, let's go to the next one. Which one of these two was intended to break down silos? So we'll start DevOps and platform engineering. You're all pretty much on the ball. That one's DevOps. Very much the idea of the DevOps culture was to break down silos, cross-collaborative teams, all those good things. Which one of these two aims to automate everything? So let's go with DevOps. Yeah, how about platform engineering? Well, it's DevOps and it's platform engineering. So you're all right. Okay, and who uses processes and tools to improve reliability? DevOps and platform engineering. DevOps and platform engineering. And lastly, can be used to improve the developer experience. DevOps, platform engineering. And you're catching on, it's both. So they're starting to look really similar now. So really, what's the difference here? So DevOps focuses on that cross-collaboration, encourages everyone to learn how the application runs, and aims from kind of self-reliance on teams. But these are very much more the cultural aspect. But then we look at platform engineering, and we're seeing much more of an engineering focus where we're treating the development teams as the customer. So we're even actually thinking of it as a product. We're now developing products for an internal team. So it focuses on providing a platform to abstract away complexity. We don't want developers sitting there going, how does this load balancer work? That's not what they're there for. And it aims for self-service. So you don't want ServiceNow with 1 million tickets in it just to, hey, can we spin up this little machine here, or I've got a new project and I just want to get a repo started. You don't want a whole heap of tickets for that. So where does this all fit in? So, because a lot of organizations are at different stages. So, and from my experience, I've seen that there's really 3 stages at the moment which organizations really fit into. So we've got stage 1, so cloud transformation and adoption. So we've done the initial uplift, we're going to the cloud, great. We've kind of got our network still tied to on-prem, because there's still an on-prem, so the network's still there, and networking hasn't really updated, so they're still like, what's the VLAN to the in Azure? And you're like, what? There are no VLANs in Azure, what are you talking about? So there's a bit of issue there, and there's lots of legacy applications. So you've got applications which are fragile, they're not ready to go to the cloud yet, they're not ready to be containerized. So you've got to do things like shifting VMs and dealing with all that kind of fun stuff. So that's stage one, which I'm sure a lot of you have either been through or are still in at the moment. Stage two is what I call DevOps adoption. So we've started to do infrastructure as code. We've figured out that just click-opting things into place is bad, and that's hard to manage, so we've said, okay, there is a way to manage this infrastructure as code. We've done some modernization of applications to cloud native. So we've said, hey, we should do containers, maybe some serverless. We've started to pull up kind of the low-hanging fruit from our platforms that existed previously and put them into the cloud. But in doing so, we've asked the developers to now know more about the cloud. They now need to be aware of what is serverless, what is the way that the cloud works, how am I doing containers, and it would really asking them to take a lot more cognitive load. And then we've started monitoring like applications at a basic level. Is it running? Is there a health check? Can I connect to it? Basic stuff. But we still don't really know how well things are running. The developers are becoming overloaded with kind of that extra knowledge. And we've mostly built a DevOps team and said, hey, these are the DevOps engineers, they'll fix it. And this is where I see the majority of organizations now. They're kind of in this place where they're like, hey, we're doing it, but it's hard. And there's like a lot of fragile parts, and our developers are crying and saying, hey, this sucks. We don't want to do infrastructure, we want to do code. And that's when we have stage 3 platform engineering, where we're really trying to solve this. So we've got infrastructure as code fully automated. No one is doing ClickOps. You've got templates to abstract away complexity. Your CI/CD is templated. And by templates, I don't mean that we've taken it completely out of developers' hands. What we've done is we've taken all the infrastructure bits, put them in templates, but still given the freedom to the development teams to, say, build a Docker file. Because they know how the build system should work. They know how their application builds. So we should still give them the power to build their applications. But then the actual kind of delivering of the container into the environment, moving it through the environments, they don't need to worry about that. That's what we should be abstracting away. And we should be doing this through a self-service mechanism. We should be having that development platform where instead of the developer raising a ticket, they should just be able to log into this platform, say, okay, here's the details of my application, here's the tech stack, go create me a repo, go get me credentials, put that in place. Automate all of these kind of tedious, like really ticket-based things away. And then lastly, we need to make sure we have monitoring and observability centralized. Now, this one's a bit of a pivotal point. A lot of people think, oh, you should distribute your monitoring and make it. I think you actually should centralize it from the point of view of if you have a central place where monitoring is accessible, you're more likely to get people to go there and look at it because they all know it's one system. We're going to go here, we're going to look at Grafana, we're going to look at dashboards. You can even have people that aren't in the team doing that. So you can have different roles. You can have SRE come and look at it without needing to get into the code, things like that. So having this monitoring observability is really key. The other key part about that is make sure security is involved in this too. You want security monitoring and observability as well, because you should be thinking of security as default, not an afterthought. It should be part of the platform. Cool. So I've just said that we want to do platform engineering. What happens to all the DevOps engineers? Where are they going to go? So instead of thinking about DevOps engineers, we should be thinking of a DevOps team. And we should be breaking these down into 3 primary roles. So we have our platform engineer that we've just been talking about, focuses on platform delivering for developers. But we also have a site reliability engineer. So they are key in making sure that your infrastructure is still running, that you have high availability, that you have disaster recovery. That's what they should be looking after the backups. And you also have cloud engineers. These are the engineers who are responsible for the networking layer. So they are still looking at, okay, how does traffic get from our public IP through our system, load balancers, kind of your API management layers. They're still responsible for all of those components, and then they work in conjunction with platform engineers. So platform engineer delivers the platform on top of this cloud infrastructure. And site reliability makes sure that it all backed up and it all keeps running and that it's all going to be reliable over time. Cool. And yeah, this is a DevOps team. So how do we achieve this? How do we do platform engineering? And what I'd like to do now is introduce you to the platform engineering iceberg. So what we have here is we have a happy little organization that has decided we're going to do platform engineering. Yay! What do we need? All right, well, let's start simple. We need source control. We need somewhere for our developers to put their code. Okay, that makes sense. We also want to store our infrastructure as code and our platform we're mostly building. We need its code stored as well, so we should be storing in here. I will preface this, most of these services are going to be Azure-based. There are other flavors available, so just substitute your flavor in if you're using a different system. Okay, cool. So we've got our source control in place, great. Then we want CI/CD. So obviously in my space, it's the same tools, but it might be different tools in the space that you're working in. But again, we want a system which is reliably able to run pipelines, do deployments. You might even be looking at GitOps or something like that, using Argo CD if you're using Kubernetes. But you need that system in place. Now we have IAC. So you've got to choose your flavor of IAC. So again, in Azure, we're generally talking about Terraform or Bicep. If you're still using ARM, please use Bicep. Just please. We don't want to see any more ARM. But yeah, if you're using like AWS, you might have cloud version. You might be using something like Pulumi. You might be going all the way to real code as infrastructure. But you do need to choose. And it's really important to choose one and stick with it, because chopping and changing can be really hard. And if you're trying to then expect your cloud engineers, platform engineers to really understand both Terraform, Bicep, they're going to be bouncing back and forth. So if you know that you're going to be multi-cloud and you want one language, choose Terraform. But in my experience, if you're just on Azure, I think Bicep's superior. That's an opinion. You can come argue with me on that one later. All right, feature management. So now we're looking at services to do with how do we manage the features of our application that's running. So are we doing things like feature toggles? Are we doing canary sites? Are we allowing all of that kind of thing to happen within our platform to actually enable developers to have these extended features, to really kind of modernize how they're doing their application? Workflow. Workflow is a huge part of this. If the developers need to track what they're doing, and even more importantly, they need to know when something goes wrong, how to track solving that problem. So it's not just enough to say, oh, well, we've got our kind of backlog and we're ticking away at that. But when there's an issue, you don't want that just to sit with a support person where you're like, oh, there's an issue and it's in my system and you can't track it. You actually want that ticket to go back to the developer, and you also want that to go back faster. You really want short cycles, because the longer the developer has moved on to another thing, the less knowledge they're going to have of the system they developed and the bug that's in it. So the faster you get that feedback cycle to the developer, the faster they're going to solve the issue. They're going to have the context still within what they're working on. Cloud providers. Obviously, I'm talking about Azure, but you can talk about AWS, GCP. If you're doing the cloud, you'll need a cloud provider. So obviously, you're going to need your platform engineers to know what services are available on it, your cloud engineers to be able to do the networking, site reliability, to understand what's going on there. So you need to have that thought of and actually working within that. Because some cloud provider like Azure has a lot of services in it which does a lot of this platforming stuff kind of for you. So you don't have to build as much. You can just look at integrations. Dev tooling. Dev tooling is still an important part of platform engineering. Your platform shouldn't just be, oh, here's a website and portal and go and create an app and you're fine. The platform is everything your developers are using, and that includes your developer tooling. Your developers are going to need support, because they're going to need to know, hey, here's my dev tool, and maybe I've got an extension which lets me remote into Kubernetes. How does that work? Developer's not going to know how that works, but a platform engineer should. And that kind of becomes part of the platform engineering role, is working with the developers to ensure that their local environment works, that they have a dev environment that they can work. They can maybe do ephemeral environments where it spins up, they test something, it spins down. So you want to be working with the developers really closely, because again, the goal of platform engineering is to support the developers. And then monitoring. So you're looking at Grafana, you're looking at Prometheus, you're looking at tools like that, Logstash. You want to be using these tools. You don't want to be rolling your own. There are plenty of tools out there that do this. But you want to be doing this in a consistent way. And definitely using something like Grafana, which is much more open and easy for everyone to use, all of your different teams, and build their own dashboards, can be really empowering for the dev teams as well, because they'll see what they want to see, rather than, oh, this tool doesn't show me X, Y, Z, and I kind of have to do something to figure that out. So we can see there's a lot of things here. Platforms contain a lot of different things that we need to bring together to kind of do that. So first things first, don't panic. You don't need everything there. You want to pick what is simplest for you. You want to start at that simple layer, and you want to say, okay, what's the first thing to do? Okay, maybe we've got our source control and we've got IAC. Maybe that's where you start. And then you want to start to slowly iterate. You want to talk to the development teams. Try focusing on, how do I improve that developer experience? How do I help them get the most out of a platform? Find their friction points. You also really want to put cost monitoring in place, because as you've got so many different systems you can bring in, the costs are going to increase. So you do need to monitor that and kind of work out, all right, where are my costs? What's increasing? Do I need to optimize some of these costs, or is this just part of what we're doing? And what's really important here too is having the monitoring, so you can show things like, hey, yes, the cost increased, but here's what we've seen as a benefit. Maybe we've got monitoring of our cycle times have increased. Maybe we can say, all right, yep, costs increased, but look at how much information we now have. We now know how our system's running, what our load is, all that kind of thing. Okay, and so we spoke a bit about an internal development platform, but what is it really? And how do we build one? So the first thing is you want to start simple. You don't want to boil the ocean with rebuilding Backstage. And I'd even posit to say that most people don't need Backstage. Backstage is a lot. It works for the company that built it, doesn't really work for that many other organizations. Which is the whole point, is that one size doesn't fit all here. Everyone's going to need slightly different things. And really, to get the most out of it, you should be building it yourself, because you want it to do what your development teams need. And that's going to be very customizable. You should also be treating it as a product. This is something you should be delivering to your developers. You should be doing releases, patch notes. You should be kind of getting your developer champions involved to say, hey, let's promote this tool within the organization, get people excited to use it. So rather than just continue to tell you these things, I'm actually going to show you what a minimal development platform looks like. So let's just bounce out here. And let's see if I can, going to just pop that. Okay. All right, cool. So what I have here is just, it's a very basic application. Now, I will make this a bit bigger. This is available on GitHub, so it's on my GitHub. You'll be able to find a link to my GitHub at the end of this. So it's a front-end application written in Svelte, so just very basic TypeScript, and a back-end written in .NET. And all this is aiming to do is to help your developers start a project. So what I'll do here is I will start up the API, and then I'll go start up the backend. Now, well, the important thing here, why do you want an API? Because later on you might build a CLI tool. So you want the flexibility there to be able to say, yes, I have a graphical front end, but I also might have a CLI tool that I really want the developers to use to speed them up. Okay. And we're running. Okay. And this is it. Not complicated. It's a page. I mean, obviously, if you're doing this past the minimal, you want to add auth and things like that in to make sure that the right people are using the tool. But if you're running it internally and you're a small organization, maybe you don't need that level of auth. But generally, you want auth involved here. Cool, so I'm going to come here and I'm going to say create your application. Nice and easy. I can give my app a name and we'll just call it test-04. And we'll say my stack is .NET. And I'm going to say, okay, go create me a repository. Cool, so this has gone and created me a repo here, so I can copy and paste this. Again, you might want to make this a clickable link. And we'll paste and go. And here we go. This is the repo. So what it's done here is it's taken a template repository in GitHub, and it's just made essentially a version of that repo from that template. And all this template had in it was it had some workflows. So it has kind of an app deployment. It has a build and push, so we're building containers. And it has a infrastructure deployment, which is kind of like your first run. So you would do this, and then you would run your infrastructure deployment, set up your base infrastructure. And then you can have your other ones running as you go through. And then we just have a basic bicep file here. And you could, at the moment, just setting up a container app, a storage account, and a key vault. All very basic things. And this is just the starting point. So you could customize this as you wanted. You could have multiple different templates. So Will, in his talk yesterday, showed a really cool thing you can do with the container registries in Azure, where you can actually put your bicep files into your container registry so that you would have your base bicep file and reference those so they're always up to date, because that's a common issue with these kind of systems, is that you would build them and then the template would go out of date. And you would update the template, but then what happens to all the repositories that have already been made off the template? Well, they're now all out of date, and you have to go and update them all. Whereas if you have those bicep files living inside a registry somewhere, and you can just use like a latest tag, then you know that as you update the core one, they're going to stay updated as well. And then there's just a Docker file, which is for your developers to fill out. So really, that sets that up. So, but what do we do next? Because that's just setting up a repo. That's pretty simple. So next, we want to actually go and register the application. So what that's doing, and that's failed to create, but that's great. So what that does is that goes into Entra ID, because we're in Azure, and it goes and registers the application as a what we call service principal, so it gives it an identity within your platform. And the main reason we're doing that, specifically in Azure, is we want to create what we call federated credentials. And this allows us to use the OIDC connection from GitHub so that when we want to deploy, we don't have to go and set up something. We're actually using federated credentials between Azure and GitHub, and that allows us then to go and do that. And then the last part here is we actually go and add those repository secrets now. Because Entra decided it didn't like me this morning, it hasn't done that, so that button's not going to work. But the goal here is what it will do is it will go and grab those federated credentials from Entra ID and go stick them into GitHub secrets. And that gives you then, through your pipeline, the ability just to deploy straight away. So ultimately, you wouldn't actually have 3 buttons. You'd have just 1 button to do this, and it would go, do all these things. Your developers would then be given the link to the repo and say, there you go, start committing your work. And they should be able to deploy straight away. So this is really the goal of trying to make this very basic platform. And then inside this, the other advantage you have here is you'll be able to see all of your applications, which means you can see what applications have been running, what their state is, have they, in this case, we know that it's not registered and doesn't have secrets, but we could see what stage they're up to. And you could then tie this into your monitoring as well, have it link back to your monitoring boards, all those kind of things. So you can really see how, from a minimal starting point, there's a lot of areas you can grow, but really just nailing these core inner parts is what's really important. Cool. So as I said, the code for all that is up on GitHub. So feel free to go do that. So what I'll do is I'll switch back now to the presentation. Alrighty. And we'll just go from here. Cool. Alrighty. So essentially now we've seen what platform engineering really is. But what's the end goal here? What is the kind of point we're trying to get to now? So this is what I think we should be trying to get to. So we should be going for the standardization of tooling. So, and what do I mean by standardization of tooling? I mean, we know what the tools we're using are. Doesn't mean that everyone must use Visual Studio, because if you tell every developer to use Visual Studio, one of them's going to say, but I like Vim, and you're going to have to deal with that. So be open to things like IDEs, be aware of them, but try and standardize to go, okay, yes, you can use Vim, NeoVim, that's fine. You can use JetBrains, Cursor, no. So you're going to have to put some breaks somewhere to say, all right, some of these are not workable, but at least talk to your developers first. And that's really key here. Speak to the developers. Don't just prescribe them things. That's the way that you're going to get developers forming shadow IT and doing their own thing anyway. But also support them. Like, they're going to have issues. Visual Studio is going to die on you, and you're going to have to solve the problem. And the developer's not always going to know why Visual Studio died. Half the time we don't know. So, but supporting them through that is a way to make sure that they're invested in your team supporting them. Internal development platforms. So we have this, it gives that self-service to the developers. It provides that standardization of infrastructure, so you know that whenever a new project happens, you know what the infrastructure is going to look like as a base. The standardization of the deployment process. Again, this is now a common practice through your organization. It's not suddenly, well, this team deploys in this way and this team deploys in this way, and now I have to context switch between the two teams and figure out why the deployment failed. There's a standard process, so everyone can be trained on it, everyone kind of know what's going on there. And then we also want to provide standardization and enforcement of security policies. As I said, we want security as default. We don't want it to something we're thinking about later. It should be at the start of every project. There should be the basic security layout. There should be security monitoring. Everyone should know what the expectations of security are. At the same time, security should be brought into this to make sure that we're not putting the brakes on at the last minute. We're not kind of building something and then security comes in and says, no, we're not going to let that happen. The earlier you get the security involved and the earlier you start thinking of that, the more likely you're all going to be able to compromise and go on the journey together and actually find solutions rather than just get stonewalled. Because it's no fun for anyone. Security people don't actually like sitting there telling you, well, caveat, some of them do. Some of them like saying no. But generally, you're all trying to achieve something out of business. You're all aiming to deliver something. So bring them along on the journey. And then, yeah, centralized monitoring, alerting, provide that easy access point for monitoring, as well as a central place to manage the alerting. So you want to make sure that that's centralized, it's alerting. Could even be centralized out of your environment. So if you have an environment that you're like, oh, we need to know if it crashes because the whole environment's down, maybe having an external platform to monitor that might be good, unless that goes down too. But essentially, for me, this is really kind of the dream state of where we want to aim to be within platform engineering. So let's do a bit of a recap. Really, what I'm saying is DevOps is a culture and is a way of thinking that encourages the breaking down of silos and the cross-collaboration of teams. Platform engineering focuses on providing ways for development teams to get their applications running and be supported. Both focus on using tools to assist in automation of tasks to deploy and monitor applications. DevOps aim to shift the responsibility to the left to the developers. Platform engineering tries to shift things to automation and away from the developers. So really, in the end of the day, it's not platform engineering versus DevOps, but instead, it's platform engineering and DevOps. We shouldn't be, these are not things that are incompatible. They are, like, DevOps is where we started, we thought about it, and then we're now evolving into, okay, platform engineering is the way we're going to deliver DevOps. So biggest takeaway I'd like you to take from this is that for me, platform engineering is the destination at the end of the current path, and DevOps is the friends we made along the way. Cool. So that was my presentation. Very much like if there's any questions, happy to have some discussion. As I said, a lot of stuff I put out here is very opinionated and may not work for everyone, but I welcome discussion on this, and I think that's how we're going to progress platform engineering further. Yep.
In my experience, I found that in platform engineering, we should not focus so much on portals. So IDP, Internet Developer Platform. So if we think platform and product, before thinking of user interface, I believe that there's so many different and actually better ways to provide an interface, a platform, a product that does not have the complexity of maintaining an API that's coded in a programming language and a user interface. All of these have complexity. I pretty much prefer thinking of the interface because there's simpler ways. Like as an example, a simple Terraform workflow could be with maybe a YAML interface on top could be much more effective than trying to invest effort in building an interface, because what you really want to invest in is those infrastructure modules and the hierarchy of it and the interfacing between them.
Yep. Cool. So just for everyone on the recording, what I'll paraphrase is that essentially you said that rather than starting with the the portal part of the development platform, what we should be looking at is the platform itself. So we're talking about the infrastructure, building up IAC modules, kind of centralizing workflows, and creating the systems which allow the automation part of solving the initial problems, and kind of working from that layer before we start thinking about, oh, well, let's build an interface and a portal that allows our developers to self-service, which is completely valid. So, and again, it's around that idea of starting small, starting with the low-hanging fruit, starting with those key things like, let's get our infrastructure in line. Let's set up the modules so we know everyone's using the same kind of thing first before we get to that golden state of self-service. And then that's a very important kind of distinction to make, is that platform engineering isn't everything to everyone. So you've really got to focus on what's going to give you the most value. The other issue there is platform engineering is very much what we call an implied value. So you're not giving value to the business directly. You're not sitting there making money for the business. What you're doing is you're improving the value that the developers can make. So it's sometimes hard to get platform engineering up and running because you've got to say, well, we're going to spend money and we're going to spend time doing this. So if you start with those kind of base platform things first, that's where you're going to show like the quickest value. You're going to say, okay, cool. Well, we took starting a new project from taking 3 weeks to taking 1 week. And you can start showing that measurement, and business can start saying, oh, okay, so I don't have to wait as long. We're not spending as many cycles waiting for projects to spin up, things like that. Yep.
Have you found frameworks like .NET Aspire helpful with like the IAC part or anything else with engineering?
Not so much yet with Aspire. It's very .NET centric. So again, in .NET houses, it definitely has a place. And I can definitely see Aspire, especially the dashboard for Aspire, being really helpful. What the current limitation with things like Aspire and also the Azure Developer CLI, both are kind of doing similar things. They're really good for sandbox environments, getting things running, getting developers running within kind of a dev environment. The missing piece at the moment is productionization. It's going from, all right, what have we got in development to how do I now set up IAC? How do I set up pipelines, environments, and moving things between the environment? That's being worked on. That is definitely something that Microsoft are aware of within that space, and that they are trying to find that pathway to improve that. So at the moment, it's great for getting things started. We just don't have the production story in line. Back to the start.
Can you sort of recommend any decent sort of views for
Yeah, so you can look at something like a service catalog is one way of doing that. So actually, I know in Azure you can look at application insights. Is actually a good way. There's some good monitoring in Azure Monitor and application insights, which actually shows you where things connect in a visual way. Yeah, well, you don't use Azure. I don't know of a product directly off my head, but definitely thinking about things like a service catalog and kind of how those services connect to each other, maybe even building a dashboard could be a good way just to say, well, here's all these services and the networking between them. Yes?
Do you think the platform engineering team is a good team for taking on common IT concerns between teams, like a common messaging platform or something like that? Would platform engineering look after that?
I think, as with a lot of this stuff, it's collaborative. It's not just platform engineering. I think definitely things like a messaging platform should be something the cloud engineering is looking at, because they're kind of looking at, okay, what is the platform doing here? Like, what is the cloud platform doing here? How do I set that up? But then platform engineering should be integrating that. So a lot of work platform engineers can do as well is a lot of integration. It's like, how do we plug different things together? So a messaging queue might be part of that. How do we deliver that messaging queue to the developers, again, so that they don't have to think about it as much? But definitely systems like message queues, like kind of automation, web pub subs, another one, for like WebSockets, they're going to be cross-collaborative. You're going to need everyone to be talking about how we're going to use this particular system. And again, that's that DevOps culture coming through, where you want that cross-collaboration between all your teams.
Right.
Cool. Any other questions? Yep.
Spoken about the cross-collaboration and sort of breaking those silos. One of the challenges we found, I guess, is how to effectively kind of communicate that with other teams without being overbearing. What have you found to work? Is it documentation? Is it restively pair programming? Is it like
Yeah. What I found works really well, and this is very much biased to my experience, is because I came from a developer background, I'm able to actually speak to developers within their own language effectively. I understand what they're trying to do, I understand the trials they're going through, and I understand what they do best, and that's not infrastructure. So really, what you want to be doing is kind of trying to think a bit from their point of view, and that's why I think platform engineers really should have exposure to programming. They should have exposure. They don't have to have the full programming background, but they should know a bit more than bash scripting. They should say, okay, I can do some Go, I can do some Python. Because then what that gives you an understanding of is, what do these people care about the most? And generally it's kind of, how do they get their code, their features built? How do they do their tests? How do they get all that working? And when you know that, then you can start to kind of talk to them on the point of view of, how do I support you? So rather than being overbearing and be like, oh, you must use my tools and you must use this, what you want to talk to them about is, okay, you want to get your feature here. How do I support you in getting your feature there in a way that is going to be consistent and that everyone can use? And really what you want to do is try and find champions within teams. So other engineers that kind of see what you're trying to do in that pathway, and like use those champions to try and communicate that within their teams, build it up. You're not always going to win. You're not always going to get there. There's some organizations where the dev team is just so under pressure they don't care. And in those ones, you're going to have to sometimes say, okay, I'm going to put this in place and we're going to maybe do a trial run, or we're going to do a pilot, and like start soft like that and then build up. I don't think it works when you try and be overly prescriptive, especially with developers, because if you're like, this is my way or the highway, they're going to find their own way. So, and that's how you end up with shadow IT and devs doing their own thing and no one having a fun time. Cool. All right, I think we're all good. So thank you everyone for coming to the session. Here's all my socials, so feel free to connect with me.